In my last video, I showed you how you could use geometry script in UE 5.0 to create a simple procedural actor where you could take an input static mesh asset and distribute shapes on the surface like boxes in this example. So one drawback of that blueprint is that you have to start with a single mesh and you're distributing objects on that mesh and everything comes out combined together. So in this example, I'm going to build on that by showing you how to do the same thing but on multiple objects. So in this example, I've got two bunnies here. These are static mesh actors I just dragged into the scene. And then I've got my boxes, again, distributed on these objects. But they're a separate mesh. They're completely separate from the static meshes. Okay, so let's look at how that works. So the blueprint itself, I won't make any of the nodes. I'll just walk you through them because it took a bit of time to set up. So this is the same as always, a rebuild generated mesh event. Then we set the target mesh variable like I explained last time. This is just a helper. And then there's this sequence node. Sequence is a really useful thing that lets you basically just do multiple steps without having to chain them horizontally. The main new thing in this example is just in this first branch of the sequence here. So essentially, in the variables for this blueprint, I have a set of target actors, and that's an array type. So what I have to do basically is collect up the meshes from each of those target actors and put them all into a single mesh so that I can make a BVH for it, which is what then I can use to do the ray casting to find those box positions. So that's all in the first branch here. So basically I allocate a new compute mesh. I call that raycast mesh. I set that as a variable. Then I'm going to loop over the target actors. And for each one, make another compute mesh, use copy mesh from component to read the mesh out, and then append that to the raycast mesh. So copy mesh from component is a node I haven't shown before. So basically, instead of copying from an asset, this copies from a component in the level. So I'm passing in the root component from each actor. So this will actually only collect up the root component mesh of each actor that you set on the input. So if you wanted to handle multiple components on an actor, this would need to be extended. But essentially this node can handle static mesh components, volumes, like gameplay volumes, like blocking volumes, and dynamic mesh components, like other generated meshes. And it has an option to transform to world. So in this blueprint, we're going to operate in world space because we have multiple meshes, and so each one has its own local space. So I've got that checked here. The next step here of the blueprint is optional. If I have this include source mesh checked, it's just going to append that accumulated mesh to the output. And so I'll just show you that part right now. So I'll turn off all the boxes. If I turn on include source mesh, you can see because it's in world space, it's directly on top. If I turn off this transform to local, then it's going to be positioned sort of relative to where this pivot is. So you can see that this is the copied out bunnies into a single mesh of these two bunnies. I'm going to put that back in local. I'm going to turn the source mesh off. Okay, so basically once we've done that, then we can build a BVH for that raycast mesh. We call that raycast mesh BVH. This is all the same as the last demo. I'm going to get a bounding box and a random stream. This is just kind of setup stuff. And then we have a for loop here for the number of boxes. Now, last time I used a random point in the 3D box and then a nearest point query. This time I'm going to use a raycast. So I'll just show you, I made a little diagram of what's happening is basically I'm getting the bounding box and then I'm using the sort of top plane of the bounding box and shooting rays straight down. And so then where the rays hit the surface of that combined mesh, that's where the boxes are going to get placed, and they're just kind of randomly distributed. So we can turn that back off. So that's this little bit of math here to get the random x and y positions, and then this node find nearest ray intersection with mesh. It outputs a hit or a not hit, as well as stuff like the triangle hit position and the triangle ID. I get to use that with the normal to align the boxes the same as last time. And then the final branch here is just the transform to local checkbox I just showed. So if we don't have that checked, then the mesh position will be relative to where this blueprint actor is placed in the world. It's a little weird because the actor itself right? Uh, the geometry for it is relative to these objects, but it still needs a 3D position. So as we move it around, you see it kind of shake. That's because of multi-threaded rendering. So it's always going to go back to the right spot when we let go of the mouse. But it's essentially being generated in world space, and then we're positioning it relative to the position of this object. And this is kind of how you have to do things if you want something to be computed in world space, but then stored relative in a mesh relative to some actor position. And then finally, we release the compute meshes. So that's really it for this blueprint. And I'll just show you that where's our raycaster here? So we've got the two elements, bunny 1 and bunny 2. We can add to the list here, and we can put in this other blueprint that we made. And you see now the points are scattered on all three of those. So essentially, we can add all sorts of objects in the level, and it'll do this distribution across all of them. Okay, that's the end of this blueprint, or that's the end of this video. I'm going to follow this up with one more showing how to do this process, but more efficiently, so that essentially this recomputation is faster. Okay, thanks for watching.